We are going to solve a couple of tricky similar triangle problems that you may see in grade 10. Now, this one is actually a viewer request. I got a sweet little message. Hello, thank you for your maths tutorials. Could you please do one on similar triangles class 10? Which tells me by your words that you're from a different part of the world, and that is very sweet and very cool. So let's look at two problems that involve similar triangles that I would consider challenge questions. They are tricky, but they're doable as long as you understand and follow the rules. So in both of these, we have to find x, the missing side. Oh, look, I found x. Just kidding. Let's go. Let's start with the first example. All I'm told is that I have to find x, and I have the two triangles, the one on top and the one at the bottom. And I'm also shown that I have two parallel lines, which is actually a good start. First things first, I actually have to prove that these two triangles are similar triangles. That means that they have to have three corresponding angles or three pairs of angles that are equal to each other. And that means that once I find the corresponding angles, I have corresponding sides, which are proportional, and then I can find the missing side, or x. So I'm looking for any angles that are obviously equal to each other. And in this case, something jumps out at me, that these two angles are opposite of one another. And I can't just write angle R is equal to angle R, so I need to write it this way. Angle PRQ, okay, with that R being in the middle between P and Q, is equal to angle SRT. Okay, again, we're referring to R here, but it's between S and T, not between anything else. And you're going to need to prove the reason, and that's because they're opposite angles. Okay, and colloquially, I call it the X pattern. And the next two angles I'm going to look at is this angle here, Q, and this angle S. And these form what's known as the Z pattern, or alternate angles. So I will write the angle PQR, with Q being in the middle there, PQR equals to angle RST, RST. Okay, because they are alternate angles. And colloquially, again, I call that the Z pattern. Okay, so then I know that angle QPR, that's this angle here, is equal to angle RTS. Okay, so again, you could say it's because they're alternate angles, or the Z pattern, or because if you have two angles that are the same, the third has to be the same because they add up to 180. So now I would write out my similarity statement. So I will start with the small one, triangle PQR. PQR is similar, and this is how I write similar, the other triangle, and we have to stay within the same order. So it would be TSR. So we just proved that the triangles are similar, and now we have to identify the corresponding sides. And it actually really helps to sketch out the two triangles separately. So this is going to be my STR. And this one has to be equivalent. So if I had S here, this will be Q. And this side I will have P, R. And let's fill in the sides so it's the same as in this triangle. Okay, here I have X, here I have 6, here I have 5. I'm just not going to write the centimeters for now. And in this one, between P and Q, I have 4. Between Q and R, I have 3. And here I have nothing. So now we can just compare the corresponding side lengths and set up those ratios. So I know S and T over Q and P, ST over QP will equal to SR over QR, as well as RT over RP. In this case, I don't have anything between R and P, so I'm not going to be using this ratio. And now I can just start setting everything up. ST is X over QP, that's 4 centimeters. SR, that's 6 over QR, that's 3. Okay, so now I have a neat little ratio, and all I need to do is solve it. I have 4 in the denominator. I'm just going to take it step by step. In order to get rid of it, I have to multiply this by 4 and multiply this by 4. These cross out. And I can just rewrite it. You don't always need to take a step, but I can rewrite it as X equals 6 times 4 over 3. 6 times 4 is 24. 24 divided by 3 is 8. X equals 8. And since my questions have centimeters, I have to put centimeters in here. And most likely your teacher does want you to show all of this work, but you can do a mental check once you figure out that your triangles are similar. If I know that 3 and 6 is double of 3 between these two, I have to know that X is double of 4. Let's look at those steps again. I have to, 1, prove that the triangles are similar, which means that the angles in one triangle are equal to the angles in the other triangle. Then 2, identify the corresponding sides. And 3, set them up as ratios between the corresponding sides, and then solve for the unknown. So let's use those steps to find x in this second example. In this example, it's going to have a few extra steps because I have to find x, but x is only part of this triangle, not the whole triangle. And I have two triangles, ABC and ADE. So again, I'm looking for the very obvious. What's very obvious? Here I have angle A, which is common to both of the triangles, but I can't just say angle A. I have to write it as angle BAC, because A is between B and C, is equal to angle DAE. Okay, and that's because it's common between the two. The next one I'm spotting is this one here, and that's because I have two parallel lines. And when I have two parallel lines, these two angles are known as corresponding angles, and they will be equal. So I will write it as angle ADE equals to angle ABC. And again, that's because they are corresponding angles, which is also known as the F pattern. And the last ones here are angle, this one right here, E, and here, C. And they're also equal because of the parallel lines, and it's an F pattern. The corresponding angles, like this, it's an F like this. Think of this as an upside down F. Or we also know that because if these two angles are equal, then the third one has to be equal as well because they add up to 180. Angle AED equals to angle ACB. Since I have three equal angles, I know I have two similar triangles. So I'm just going to rewrite it as triangle ABC is similar to triangle ADE. So now I have to find the corresponding sides. And again, it super helps to sketch the two triangles out separately and label them. And this one's a little bit easier than the other one. Here for A, between A and D, it's 6. I'm just not going to write centimeters for now, just to keep it clean. And this is 4, and this one I don't know. And here, between A and B, it's not X, it's actually, if you see X, plus 6. And this one is 10. Now I can start setting up the ratios. Since I know that these are similar, I can say AB over the corresponding side, AD, equals to BC over DE, which also equals to AC over AE. Okay, so I don't have any information between AC or AE, so I'm not even going to bother it. Now I can just fill in my values. So AB is X plus 6. AD is 6. BC, 10 over 4. Write this in brackets for now, and I'll explain why later. So I have 6 in the denominator. I need to multiply both sides by 6 in order to get rid of it. So I can rewrite this as X plus 6 equals to 10 times 6 over 4. 10 times 6 is 60. 60 divided by 4 is 15. So I will rewrite as X plus 6 equals 15. And now I still need to isolate X. So I subtract 6 from here, 6 from both sides, so minus 6. And I know that X equals 15 minus 6. I'm just doing some extra stuff here. 15 minus 6, X equals 9. And since my question has centimeters, my answer should have centimeters as well. Okay? And so now if I think about it, if X equals 9, 9 plus 6 is 15. And 15 is 1.5 times of this bottom side, 10. And 6 is 1.5 of this bottom side, 4. So this value of 9 makes total sense to me. That's a double check, although you do need to go through this work in order to get full marks. Here are those steps again for the similar triangle problems. Feel free to take a screenshot, and if you're ready to move on to trigonometry, check out this trigonometry playlist, as well as these other math tutorials on this channel. Thank you to the viewer who asked for this example, and I will see you next time.